All right, we are going to revisit significant digits and a couple of the examples that we use significant digits. And the examples I'm going to use are from your first exam. So if you have your exam there, you can grab it and go over it with us, or just take a look at each of the examples, and then if those kinds of questions show up on the second exam, you'll be ready for those as well. So here's our numbers that we're trying to find significant digits for. Okay, so we know that any number 1 through 9 is automatically a significant digit. So the 2 and the 6 are significant digits. Anytime a 0 appears between two significant digits, it's automatically a significant digit as well. So 206 has 3 significant digits. So let's take a look at the second example. Again, the 2 and the 6 are significant digits. A 0 in between is a significant digit. And now we have to think about this last 0. Now, if we were to write 20.6, it would mean the same thing as 20.60. So if those mean the same thing, then that 0 must be there for an important reason. And the reason it's there is to tell somebody that we didn't stop measuring at the tenths, we measured clear out to the hundredths place. And so any 0 behind a decimal over here on the right is considered a significant digit. So 20.60 has 4 significant digits. Okay, let's take a look at this number. Again, we know the 5 and the 8 are significant digits, so we're wondering about these zeros. Now, if these zeros were not here, this 8 would not be in the thousandths place. So these are placeholders, and they're important to make the magnitude of this number 58 thousandths. So in that case, these zeros are not significant digits. They're just there as placeholders. This number has 2 significant digits. So we have zeros on the right in a decimal are significant digits. Zeros on the left in a decimal are placeholders, and they are not significant digits. All right, our last example, the 1 and the 6 we know are significant digits. If I wrote this number without those zeros, I would have 16 instead of 1,600. So again, these zeros are placeholders, and as placeholders, they are not significant digits. So this number has 2 significant digits. So if there's a decimal and there's a 0 on the right, it is counted as a significant digit. If there's no decimal, these numbers are placeholders, and they are not considered significant digits. Now, it's important to be able to count significant digits because we use those ideas when we're doing rounding in several of our applications. So again, I'm going to look at another problem that was on the exam. This was an area problem. And the area of a rectangle is length times width. So 19.3 centimeters times 5.8 centimeters. So there's a number, 111.94. But I need to round that off. So now I'm going to go back to my original two measurements and count the significant digits. 5 and 8 are significant digits. 1 and 9 and 3 are significant digits. So one of my numbers has 2 significant digits. One of my numbers has 3 significant digits. We always pick the least number of significant digits. So I want to round this number to 2 significant digits. Now this one tells me not to round that one up. I do need to put a 0 in here as a placeholder so that this stays in the hundreds place. Now up here I have centimeters times centimeters, so my units on my answer are centimeters squared. So if your test said rounding on it, you may have had the correct number, but you didn't have it rounded to only 2 significant digits. Our next example will come from your homework, and it's a conversion problem. There was a race that was 100 meters long. And the racer finished it in 9.85 seconds. And we wanted to convert that to miles per hour. So I wrote miles per hour in our fraction form so I could help get started with this problem. Now we want to convert these numbers to miles per hour. Miles is a distance, so I want to put the distance at the top of my fraction. And since I want hours, which is time, I want to put the 9.85 seconds in the denominator. So this was interesting. We looked at our goal up here to figure out how to set up this first fraction. And that first fraction looks different than anything we've had before because we have numbers in the numerator and the denominator. So now I want to make the conversion from meters to miles. Meters are part of the metric system. Miles are part of the American system. So if I look through the American metric conversions, I have centimeters to inch. That seems too small. Inches to meters. That's not bad. I have meters. Or kilometers to miles. Since I'm dealing with larger things, I think I'm going to use the kilometers to miles conversion. By the way, if you used the other one, you will have different conversions, but we'll come up with the same answer. Now, since I have kilometers to mile and I'm starting off with meters, I need something that will convert my meters into kilometers. Those are metric conversions. So if I go to the metric conversion box, I find that 1 kilometer equals 1,000 meters. When we shortcut writing our units, M means meters. Notice that I try and write miles out so that my meters and miles don't get confused. Some people will shortcut miles to just MI, which would be okay also, but I have a hard time thinking of that as miles, so I just write it out. So that should convert all of my meters into miles, but I also have to convert seconds to hours. Those are time conversions. There are 60 seconds in 1 minute. Again, a good idea not to use just the word M, or just the letter M to stand for minute. And there are 60 minutes in 1 hour. And that should convert my seconds into hours. So let's try and write these out so that our units cancel. So I have the meters to cancel, so I'll use this one. 1,000 meters is 1 kilometer. And the meters will cancel. I still want to get from kilometers to miles, and I want the kilometers to cancel. So the miles are what I wanted to get to. That was my goal. So I'm going to start working with the seconds, and I want seconds to cancel. So I'll put the 60 seconds up here. Now I want the minutes to cancel. Make sure that you use the minutes to hours one. So we want to get to hours as our goal. Now if I look through at what's left, the miles were not canceled in the numerator, and the hours were not canceled in the denominator. So our goal was to get to miles per hour, which I have. Great. So let's go back and look at the numbers then. So I have 100 times 60 times 60. And 9.85 times 1,000 times 1.609. On my calculator, I'll want to group the numerator and the denominator. Now I can write times 60 times 60, or I can write times 60 squared. So there's our answer. Now let's figure out how many significant digits we're going to actually need. 9.85 has 3 significant digits. Okay. 100 meters, normally I would say has 1 significant digit. However, this was a race, and I know that they measure races very accurately, and in fact that probably was measured to something closer to maybe the nearest centimeter. If they're going to time people to 1/100th of a second, these courses are measured quite accurately. So there should be at least 3 significant digits here. This is a little tricky, so if you're uncertain about this kind of significant digits, it'd be a great time to ask a question, shoot me an email before you just rounded this number off to 1 significant digit, especially when they're measuring their time so accurately. All right, so I'm going to round this off to 3 significant digits, because even if this had 5 significant digits, we would go with the smallest number of significant digits, which would be 3. So 3 significant digits, that would be 22.7. And miles per hour. Which I almost think is incorrect, because that's amazingly fast for a person to run 22.7 miles per hour, but that is the accuracy for that world record holder. All right, let's try another one of our examples. This one is also from our homework. Now when we're writing units, G stands for gram. You may never have seen this MOL before. Actually, it comes from chemistry and stands for molecule. The nice thing about doing unit fractions is this could be a Martian unit. As long as we just treat it as an MOL all the way through, we shouldn't have any difficulty. And we don't really have to know what it means to be able to do the math. And that's a liter. All right, so when we're doing these fractions, we start off by looking at just the numbers. And again, because we have a fraction, we want to group the denominator. You could group the 49, but you don't have to since it's a single number. Right, and the answer is 0.25. Now you might be tempted to not think about significant digits, but in many cases you still need to. It's possible that you need 3 significant digits on this number, or maybe only 1 significant digit. So let's go back and count the significant digits on our first numbers. 49 has 2 significant digits. 98 has 2 significant digits. Now we know that 2 is significant, and this 0 is behind the decimal point. So it is not a placeholder, it actually is a significant digit that's measured to a higher degree of accuracy. So all of these numbers have 2 significant digits, and so does my answer, so I don't need to round this one. All right, now let's go work through the units part of this problem. We've got grams divided by grams over moles times liters. Okay, well that's the same thing as grams over, and we'll just make a single fraction on the bottom, grams times liters. Now there's some students who are doing some canceling at this point and then not quite sure how to write their final units. So I don't recommend canceling when you have a complex fraction. You want to go through the point where you rewrite this first as a division problem. Because you have to remember where the large fraction divided by sign is. So it was G divided by G times L over mole. All right, that's not a place where we can cancel yet, so we're going to rewrite it one more time. And now we're going to change that divided by sign into times the reciprocal. So we're rewriting the G divided by as times. And reciprocal basically means that we're going to switch what was in the numerator and what was in the denominator. So MOL is now in the numerator, and grams times liters is now in the denominator. Right, this grams, because it doesn't have a fraction, is over 1. So these grams can cancel. And in terms of units, we're left with MOL on the top over liters on the bottom. So our final answer is 0.25 MOL, or molecules per liter. Okay, I want to do one more example that does not use significant digits, but does use rounding rules. And this also was a problem that was on your exam. This was a perimeter problem. And the shape of the lot was in a triangle. So it's 27 meters. And this was 77.82 meters. So those were measured very accurately. And this side, because there was a lake in the middle that they had to go across, was just about 83 meters. So to find perimeter, we add up all the sides. And a lot of you answered that the perimeter is 188.43 meters. Now the problem with that answer is that if I look at it, I think, well, gee, this perimeter is measured clear to 1/100th of a meter, which is a centimeter. And it turns out that because this side was approximate, these last digits could easily be very different because this number only has precision or place value to the ones place. So if I only know the answer to the ones place, when I come down here I should only know the answer to the ones place. So when we're doing perimeter, you should think about place value and round your answer, in this case, to the ones place. Notice when you're adding meters, we don't change the exponent. Meters plus meters plus meters just gives us meters around the outside. So again, if you had a rounding or a place value comment, it's because when you're doing perimeter, we don't use the significant digits, but we do use place value to round to, because this last place up here is where we're a little uncertain. One person might have measured it as 83, somebody else as 82, somebody else as 84. So the questionable part is in this last place only.